Welcome back, everybody. Today we're going to be talking about our utility function, the math behind this in order to process a decision. We'll spend a lot of time on this, but I do want to walk you through an example of how we would actually process this formally in a math way. And so I've got the utility function written out here where we addressed it in brief before, but we've got a couple of math components here that whenever we have a value greater or equal to 0, we're going to say, give me that value and take it to the alpha power. And so alpha, we said, is this diminishing value sensitivity where we are not ignoring the fact that not all dollars are created equal. That's what we established in the expected utility function, and we're going to keep that. And we can actually apply that in both domains, as we'll see. That's our diminishing value sensitivity. And then down here, we have for any losses, we have the negative loss, so that'll make it a positive number. And we're going to also apply the diminishing value sensitivity because we have that in losses as well. And then we're going to apply the negative loss aversion coefficient. And just because we have these two negatives, just make it so we can actually do the math here with this alpha, and then also to make the net output negative in our value function. So if we follow these rules, we're going to use K as our loss aversion coefficient. Now we've got what we need to roll as soon as we put the assumptions in. So I'm going to say our loss aversion coefficient is going to be what we've been using before, 2.25. Typical diminishing value sensitivity is going to be around 0.88. And that gives us a similar function to our natural logarithm that we've used in previous videos. All right, so now let's lay out the coin flip. We've got a 50% chance that we would gain $200 and a 50% chance of a loss of 100. So now let's see if we would actually take that, and we'll compare it to not doing anything at all. Easy math right there, 100% chance of $0. All right, so now for the top, we're going to use our utility function here. That means we're going to take 200. And it's a positive number, so we're up here to the 0.88 power. And that's going to give us 105.90. And we're going to multiply that by 50%. And that will give us 52.95. 52.95. Next, we're going to use this for the loss. We're going to use this function. So negative K, or negative, is going to make this positive. So I've got positive. I didn't misspeak there. Sometimes I do misspeak. I did not misspeak there. Negative is 100 to the 0.88 power. And then we're going to also multiply negative 2.25 there. And we're going to get negative 129.47. Multiply that by 50%. And that's going to give me negative 64 and what? 74. And then what we do is we'll net that together. And I can see that is going to be a net 11. And what is that? 0.80, 11.80. And B is 0. So when we do all this math, our decision finally nets out to a negative 11.8. And we say, no deal. We're not going to take this coin flip based off of our prospect theory utility function. So we take this, and now we have our decision that we can be confident about. So the next and final question of this math is, all right, and you might have thought about this before as we were doing other coin flips. What about if we did more than one coin flip? How would you feel about that? Would you take me up on that? Because I might switch my preference. And so now we need to determine how we will calculate this. This is our introduction to what we're going to talk about as our reference point on which we base our gains and losses off of. All of that is predicated on reference point. And so when we're talking about two different ways of calculating these, if we did two coin flips, let's say we're going to do two of these. There are two ways of calculating it. One is segregation, and the other one is integration. So segregation, keeping things separate, which means if we segregate our decision making and we do more than one coin flip, well, after the first coin flip that we decline, we're going to say no. But when we segregate, that means we move our reference point to reset. So if we reset our reference point after every coin flip, the answer will always yield no, based on our prospect theory utility function here. But if we integrate our utility function, now we can start playing with some new numbers, because I'm going to integrate both coin flips that I'm going to propose here into our utility function. So let's see what that looks like. Now remember, if we have a 50-50 chance of a gain of 200 and a loss of 100, if we do two coin flips, it stands to reason that there's a quarter of a chance that we will win twice, and that will net us $400. There's a 50% chance that we will win one and lose one. So that'll be a net gain of 100. And then there's a 25% chance that we will lose $200 if we integrate both into our value function. So then now we rerun the numbers to determine whether or not this will yield a positive or negative function. I'll go back to the black marker. And for both of these gains, I've got 400 to the 0.88 power. And I've got 100 to the 0.88 power, which is going to give me 194.9 times 25%. And that'll give me 48.73. 100 to the 0.88 power gives me 57.54 times 50%. That's when we win one and lose one. And that comes out to 28.77. And then if we lose 200, that is negative 2.25 times 200 to the 0.88 power. And that gives me negative 238.28 times a quarter, or 0.25. and that's negative 59.57, almost there. Net these three numbers together, 48 plus 28 minus 57, and we get a net utility of 19.93. And let's take the bet. If we integrate our utility function. All right. There's a lot of math going on here. That's good for you. I'm happy for you. If that's not, stay with me because we're going to talk about some more fun aspects that is not math related. So thanks for hanging in with me. Have a great day. We'll see you on the next video.